It seems that our models for the development of the early cosmos have finally had their day. The James Webb Telescope has now detected a whole series of mysterious structures from the early days of the universe that shouldn't actually exist all in this form, well, at least on paper. But because the cosmos is obviously not very interested in our models and theories, Webb has already identified 6 mysterious galaxies that appear much too large and massive for their time of origin, a few 100 million years after the Big Bang. And now the most powerful space telescope of all time has already captured the next mystery in the heart of a galaxy that already existed when the universe was only 770 million years old. Webb detected a colossal black hole of over 1 billion solar masses. Experts have no idea how the gravity monster was able to grow to such dimensions when the universe itself was still in its infancy. Could it be that we are dealing here with the remnant of a previous universe? After all, we must not forget one thing. The Big Bang Theory is currently coming under increasing criticism, and more than a few researchers consider it more likely that the cosmos is in fact undergoing an eternal cycle of decline and rebirth. Good things, or rather big things, take time. Astronomers basically assume that the stars and galaxies of the universe have changed enormously over the last 13.8 billion years and only became larger and more massive over time by absorbing gas from their surroundings or merging with other galaxies. No wonder, since our current cosmological models suggest that in the early days of the cosmos there simply wasn't enough normal matter to form galactic associations the size of our Milky Way today, and so it came about that the experts expected at best tiny baby galaxies for this early cosmic era, and were consequently all the more astonished when the images from the James Webb Telescope showed that this prediction simply does not match reality specifically. Webb tracked down 6 galaxies whose light took more than 13 billion years to reach our earthly eyes. By implication, the structures already existed when the cosmos itself was only 500 to 700 million years old. But despite this, they already had up to 100 billion solar masses, and that is a problem, to put it mildly, after all the mysterious structures with their astounding dimensions are in stark contradiction to current cosmology, and unfortunately the vague explanations also lead straight to the next research dilemma. On the one hand, it could be that the density of matter in the young universe was 2 to 5 times greater than our model allow, or on the other hand, that the galaxies grew in a way that is completely unknown to us. So far either way, our understanding of early galactic evolution would have to be fundamentally re-evaluated, and it seems that this now also applies to what we thought we knew about black holes for a long time. Astronomers assumed that the bizarre mass monsters at the centers of galaxies grew in much the same way as their galactic environment itself, that is, by accreting more and more mass due to their immense gravity and detail. The matter that falls onto a black hole forms a rotating hot bright accretion disk that constantly feeds the structure inside in the case of supermassive black holes, which have millions or even billions more mass than the Sun. An active galactic nucleus, a so-called quasar, is formed. In the course of this, in principle, quasars are among the brightest astronomical objects of all. More precisely, the galactic nuclei appear so bright due to the emitted radiation that they literally outshine all the stars in their galaxies. The reason for this spectacular glow is that the gravitational energy of the accumulated matter is converted into radiation, and since the energy of the accreted matter leaves the quasar to a certain extent in the form of radiation, while this radiation simultaneously exerts counter-pressure on the sliding matter, the system regulates itself practically by itself and slows down the further material incursion. In other words, black holes cannot grow arbitrarily fast. But how is it possible then that so many early examples of these objects are so inexplicably massive when normality becomes a problem? Well, that is precisely the crucial question, and in recent years, the experts have already found several young quasars in the early universe with black holes of up to 10 billion solar masses slumbering at their centers. Could it be that the hunger of these cosmic premature babies was satisfied by a different feeding mechanism, that these black holes somehow managed to accrete gas much more efficiently than their modern counterparts? Alternatively, the scientists suggest that the mass of the quasars was erroneously overestimated due to the effect of dust, And while past observations unfortunately did not lead to the solution of the mystery, the revolutionary James Webb Telescope now makes it possible to look into the hidden secrets of quasars more closely than ever. In fact, its mid-infrared instrument, or MAI for short, is up to 4.00 times more precise than the instruments used in previous research periods. And so it came about that the experts from the Max Planck Institute for Astronomy used their observation time in January 2023 to take a closer look at what was then the most distant quasar known, christened with the scientific name J120 plus 0641. We are dealing here with an active galactic nucleus that already existed at the time of the cosmic twilight, and thus only 770 million years after the Big Bang. In the course of his investigation, Webb not only captured an image of the structure, but also a spectrum, or in other words, the rainbow-like splitting of the light into different wavelengths. Ultimately, however, the scientists were perplexed to discover that the young quasar appeared despite a mass of more than 1 billion solar masses to be, and I quote, shockingly normal. This applied on the one hand to the dust torus, the enormous loose ring of dust that typically surrounds the accretion disk, and on the other hand, to the accretion disk itself, which, as mentioned continuously, supplies the black hole with new material. But since neither the dust ring nor the inner disk differed noticeably from those of today's quasars, the experts had to content themselves with the finding that their mystery had only deepened further. In other words, not only the supermassive black holes, but also their feeding mechanisms were already fully developed when the cosmos was just 5% of its present age. Farewell, Big Bang. A fascinating and important topic that immediately comes up is whether we have already been wrong about the early history of the universe, or if we are all wrong about its actual origin, given how drastically real observations in space diverge from our theoretical models. The EXP expansion of the universe, which started with the Big Bang and continues to this day when experts look at this development in reverse, allows them to calculate back to the starting point at this point. However, it should be noted that the corresponding theories explicitly do not deal with the actual Big Bang, but with the time immediately afterwards, so the theory is still accompanied by many unresolved mysteries and some serious problems. The Big Bang basically describes the simultaneous creation of matter, space, and time from a previous singularity around 13 billion years ago, but how can we even know that today? The catch, though, is that this would be in direct opposition to the so-called uncertainty principle of quantum mechanics. But that's not all. The theory of relativity also has issues with the occurrence of singularities because, in fact, Einstein's well-known work loses its validity in the Planck scale. However, there is a model known as the Big Bounce that avoids these fundamental issues by quantizing space-time, which avoids the problematic singularities. What does that mean? Well, basically we are dealing with a cyclical model of the universe, and the first question is, what if we consider the end of the universe as the beginning of a new universe with scales increased by several powers? Because whether it's the Big Crunch, the Big Chill, or the Big Rip, even though the individual theories differ in some details, they all lead to the end of the cosmos. But what happens after that? Well, either nothing or a new beginning. Just as some zeros were dropped during the inflation of the 1920s, so that a loaf of bread no longer cost a few billion Reichmarks, it is also possible to shrink the gigantic cosmos in space and time by redefining the scales of time and distance. Since the reduced wavelengths of the radiation then correspond to much higher temperatures, one would consequently have a new Big Bang, and this cycle can be repeated infinitely, often because it is simply always set one scale level higher. Nikampusi from the University of New Haven also believes that the birth of the cosmos did not happen at all, as generally assumed, and that something existed before that. And yet, the theoretical physicist approaches this complex topic from a slightly different direction. He is in fact convinced that our world originated inside a black hole. According to this, the accreted matter would eventually reach a point where it can no longer be compressed. And although this primordial seed may be incredibly tiny, it still weighs several billion solar masses since black holes rotate at almost the speed of light. Enormous torsional forces act on the nucleus as a result. It's not Only compressed but also twisted, just like a snake toy that is just waiting to burst out of a can ultimately. The germ in the black hole can, proverbially, burst open and set the creation of a new universe in motion. However, we would then be dealing with a cosmic gateway that can only be passed through from one side. But if someone falls into a black hole in the Milky Way, it is conceivable that he or what is left of him would come out in another cosmos. Our own universe could therefore be the result of another preceding cosmos. While the germ of this mother universe was growing inside a black hole, it burst open 13.8 billion years ago and has been expanding ever since, which means nothing other than that we may still be hiding behind the event horizon of a black hole. And if you would like to expand the event horizon of your YouTube homepage with our videos, please feel free to click subscribe now, join our community, and never miss a new post from us again. We'll see you soon.